Okay. So, hello and welcome to Tech Simplified TV, and a very warm welcome to the Semiconductor Podcast. We are back with another exciting episode, and today our guest is Mr. Arghajit Basu, ASIC Director of Juniper Network, and most surprisingly, he is running his team from Kolkata. Why I have used that term surprisingly? Because Kolkata is not considered as a tech city with respect to VLSI, although he is running his team successfully from this city. So let's welcome him. Welcome, sir. Thank you for accepting our invitation.
Thank
Uh,
you. Thank
so
you for
let
me.
let's start with your story. How you started in VLSI, ended up in Juniper Network. Your journey.
Okay, yeah, let me tell shortly my journey. So, I have done bachelor's in electronics and telecommunication engineering from Jadavpur University a long time back. Then I completed my master's in microelectronics and VLSI from IIT Kanpur. And then I started my career at Sasken Technologies. We are focusing on the design of wireless LAN baseband logic. I was part of that. Then I moved to InSilica Semiconductor. It was a startup where I worked on designing wireless LAN MAC layer, and then I moved to Insilica, which was also a startup, and there means in this Insilica, which was working on 802.11 IE. This is basically wireless LAN standards. Then my
Okay.
next role was another startup called TrueSpan Semiconductor, okay, which ultimately got acquired by a company called Surf Technologies. There I specialized in digital wireless video broadcast technology. Okay, so after that I joined Juniper Networks, my current company, as a individual contributor. Then in Juniper I contributed to several high impact projects, including development several fabric switch ASICs, and now I'm here as a ASIC director.
Okay. So when you joined Juniper from beginning, you are in Kolkata.
No, no, no. So I was in Bangalore. Okay, so most of actually my entire career was in Bangalore only. So I joined Juniper Bangalore. Around now it is almost 3 years back. We started our Kolkata office, and that I am now here for last 3 years. So I moved from
Okay.
Bangalore to Kolkata. Yes.
Okay. Okay. So I mean, ASIC. So your career is a quite mix of electronics in terms of VLSI and at the same time networking, because both the things are required. When you are not sure what you are, why you are making the ASIC, then it's without any knowledge of end the result what you need, you cannot make that ASIC, because it's application specific. So in your field, both electronics in terms of VLSI and communication, both the things you require to understand it, you and your teammate, everyone.
Correct. That
Okay.
is true. Yes.
Yeah. So what the most challenging projects, not in terms of any secret information secrecy you should maintain, although what you learned, your career is a long career, now you are in a senior position as a director of ASIC. So challenges, how you handled it, because in a big corporation like Juniper, you have came across many projects, high value
Correct.
project and challenges.
Correct. So, if you see, like nowadays, which we see is that the clock frequency of a ASIC, if we like which clock it is running, right, that is increasing a lot, right? Like now in gigahertz. Okay, if
Hmm.
you see in gigahertz, so it is in actually your time to do your things. Every clock cycle is in nanosecond or less than that. Like multiple gigahertz means in comes down to picoseconds. If you think about that, like if you simplify it, like 1 nanosecond is 10 to the power minus 9, okay,
Hmm.
second, right? So 1 picosecond is 10 to the minus 12 seconds. So you can see what is the minimal time you get to do things, right, in a single clock cycles. So then, so obviously we cannot do all your processing in one clock cycles, right? So you need to have multiple several clock cycles to do that. we in our ASIC domain we call it pipeline design. Like we pipeline means it is kind of stage design, you can say kind of a stages, right?
Hmm.
One stage, like multiple stages, each stage
Hmm.
can do few things and all those things. So in this multiple stages design, it is very complex to do because you have to take care of several things. First of all, this so less time you have to do the processing and you have to meet the timing requirement, right? If you don't meet timing requirement, your chip doesn't work. That is one
Hmm.
challenge. And then different stages should talk to each other, right? Because one stage is
Hmm.
going ahead, another stage coming
Hmm.
back, and all those things. In our term, we call it called bypasses. Like we have to bypass some stage or something like that, right?
Hmm.
And then memories are there, so these memories should work at this frequency, and working with these memories and all those things, floor planning. So that becomes a very very challenging project, and like squeezing all this logic in a smaller and smaller and smaller dice, right? It is very complex nowadays. So that's why ASIC design, you might already know that fabrication of this ASICs takes crores of rupees,
Yeah.
right? So that's very expensive. And the problem is the main challenge in ASIC design versus let's say software is like if you in software, let's say you do a mistake, right? You can correct it in 1 hour, 2 hour, 1 week, 2 week, and fix it and give it, right? But in ASIC, if you do a mistake, you have to refabricate. Means all those crores of rupees, it is gone
All
down the
whole batch is gone.
gone, right? So that is one problem. Money is one
Hmm.
problem. Next problem is nowadays one ASIC fabrication takes 6 months. Like if you give it to the fabrication, like all this TSMC or Samsung or whoever, right? You give them that, okay, can you fabricate this ASIC and give it back to me? They'll take 6 months to give you back the ASIC die. So it is not only if you make a mistake, it is not only the money, it's the time also. Time means nowadays, right? Time is money, right? Time to market. So you're losing the market, right? Your competition will take out the market.
Hmm.
So this combination of these things is making the ASIC design very, very challenging and complex these days.
So when you started working on which node at, and now you are
I,
working.
I am currently we are working at 3 nanometer. I
Okay.
started my first step out was 40 nanometer.
Okay. So how it changed over years?
So actually, if you see, for I work in front end ASIC design, like design and verification side, not in physical design.
Mm-hmm.
Physical design actually changed a lot because every node comes, there are new rules, new things, new everything, right? New libraries, new everything. So it changes everything. Front end changes like whatever I just now told. Now we have to squeeze many things together. So all this, see, when I started, my clock frequency was 100 megahertz to 200 megahertz. I started wireless. Anyway, wireless clock frequency is little lesser. Okay, but now I am working at like 1.5 gigahertz and like that, more than that, right? So that changes, right? That changes your design because now you have to, we cannot do a lot of things in one clock cycle. Earlier we can do a lot of things in one clock cycle. Those
Hmm.
things have changed, right? Now power is changed, your timing is changed, you cannot now squeezing more things together. So all those things are actually changing a lot. Okay, it changed a lot.
Okay. And what do you think? In coming decade, what more things will get changed?
Yeah, that is actually very difficult to answer. What will happen? We are seeing that every year things are changing, right? Now we didn't know
So
this
fast.
ChatGPT, AI, ML came, and it changed everything, right? Like it in 6 months, like everything changed, right? The way we do, way we think, what is there, the jobs is lost everywhere, and so it's challenging. So why what I feel is that yes, the power will be one of the major concern that we are facing. That power consumption and the cooling of this big ASICs, it is becoming a major concern. So some things which is already started called liquid cooling. Okay, means
Hmm.
earlier we used to cool by air, right? Giving a fan. Like if you see your laptop or PC, is
Hmm.
a fan is running, right? So now what they are starting is doing liquid cooling. It may not come to your laptop and PC now, but a big systems like networking
Oh,
systems, they started with liquid cooling because they are not able to cool it in air cooling
which
method.
are powered for 24/7 kind of
Yes, yes, 24/7 running, right? Everything is
running
so
always. So, I mean, how ASIC design contributes to enhancing networking performance. And
Yeah.
you are
So if you
doing
see,
ASICs.
yeah, yes, I am doing ASICs for networking only.
Mm.
So
So,
if you see what is ASIC, ASIC is customization of specific task, right? So earlier means long time back, they used to do networking using general purpose processors, right? But ASICs will allow to optimize for a particular networking task like packet processing, encryption, routing. Okay, so this leads to faster and more efficient processing compared to general purpose processors, right? And also
mhm.
scalability, right? We can design the ASIC to scale. With network is growing, right? Every every year it is growing. So you can scale the ASICs larger and larger system to handle more data, right? Without compromising the performance. And one of the major thing that is coming up these days is security, right? So
Mm.
networking ASIC can incorporate advanced security features, okay, into hardware like MACsec and IPsec, okay. So this encryption and decryption, actually doing encryption and decryption in general purpose processor is very expensive, like because it's very competition task, right? Any competition task processors is slow, right? So if you can do that in ASIC, it is very well, right? So also cost efficiency, though initial development costs, as I told, ASICs are very high, but long-term cost efficiency is beneficial. Like if you do a specific purpose task for specific ASIC, it will take very less cost to build the system, right? Once you develop, it is developed, right? And so you can integrate different devices, different ASICs together, okay, and then it will be like very easy to do the things for networking also. So this is
Okay.
specific about networking. Yes.
Okay. So, as much I understand that if three things has to handle at the same time, so you are separating three things and specific their IC this way, so that the single type of work can be handled more efficiently. This way,
Yes.
is it like that?
Yes. Yes. It is can
Okay.
handle in parallel. So
In
ASIC
parallel.
can do things in parallel, right? To
Hmm,
all the
hmm,
process in ASICs are running in
hmm.
parallel, right?
And what are the key factors when we consider the design of a high performance networking ASIC compared to the other? What are the key factors? Like you said, like time to market, money,
Yes.
efficiency.
And
What are the key factors?
yes. So you can do high performance. So performance is the first major key factor, right? You have to deliver high performance,
Hmm,
right, for that
hmm,
networking. So that is one of the key factor which is essential for our modern networks, right? Like data centers, high speed internet services, right? And energy efficiency. If you do, since ASIC is doing that specific task, it is not wasting it is power to do something else, right? So that way it is like more energy efficient, okay, though it is very like high power, it is more energy efficient than the general purpose compressor. And one of the major reason for doing ASIC is reduced latency. So nowadays if you do any financial transactions, stock market trading, right, you need reduced latency. Okay,
hmm,
so
hmm.
ASIC can do, since it is doing that in the hardware, it becomes very less latency, right? And this all this real time video streaming, online gaming, right, all those things needs this reduced latency. So that is what we need nowadays.
Okay. So AI and ML, these two are buzzword now and making all the buzz all around. So does is this thing have any impact on ASIC and networking sector, AI
Yes,
and ML?
we have it already, and though we are talking about AI ML a lot in last maybe 1 year or so, but this was there in our ASIC design flow earlier, means more before that also, right? First thing we used to use and now also use is called automated layout design. Like so, AI can automate the placement of routing of different components like memories or your modules and all in a chip, right? How to put what to put where, right? That is a very, it is a kind of a NP complete problem because you don't know, there is no correct or wrong, right? What is the optimized way? So that is helping. So machine learning also helps like predictive modeling. So models can predict performance and thermal characteristics of an ASIC. If you give some inputs, it will predict that oh, this is the thermal characteristic and performance which will allow us to decide that which way to go, right? Then there is something called the dynamic voltage and frequency scaling, DVFS, right? So AI algorithms can dynamically adjust the voltage and frequency of the ASIC to optimize performance and power consumption according to the workload. See, if workload is low, then I can do reduce voltage, so I'll save the power, or reduce the frequency to save the power. We need more workload means we increase the frequency. So if you see nowadays, your most of our ASIC comes with a range of frequency. It will tell that, oh, it will run from 2.4 gigahertz to 3.2 gigahertz, right?
Okay.
That it will scale accordingly, right? So this was already there. Okay, if you see, it was there 2 years back also. Also,
Smart and
like,
efficient.
yes, smart and efficient, and we do fault detection. For fault detection also, it can predict that where the potential failures in the ASIC can be, right? And there is something called correction. So AI algorithms can detect and correct errors in the real time. Okay, so improving the real reliability of the networking data center, right? So that is, these are the main things we see. Also security also, right? So anomaly, right? So if a machine learning model can detect that there's some, the pattern is little different than usual, so it will tell that, oh, there may be some attack is happening, right? So some security attack is happening, some threats are happening, so you can take some actions. So these
Hmm.
things, there are a lot of
That's very crucial for a networking company. Very
yes,
crucial.
yes, very
And
crucial.
chiplet and heterogeneous integration, that are two very emerging trends. So uh, these trends are integrated in ASIC for networking. And
Yes, yes,
okay.
we have it integrated, because mainly if you see the we are like hitting kind of the end of Moore's law, right? So we are not
Hmm.
able to integrate as double the things in 2 years and all. We are not able to do. So what is happening, if you want to do more performance and more data and all in single ASIC, your ASIC is growing too big, right? So to hand this, if the ASIC is big, as you know, the yield will become low. So you'll not get much yield. So your cost will be very high of that ASIC. So nowadays, that's why what one of the reason for this is they're doing, they're cutting the chips to multiple we call chiplets. So each chiplets will talk to each other in like some SerDes and all those things, so that so our each die size will be low, but it in a single package it will be lot of dies together. So we call each die, will call it chiplet, and the package
Hmm.
will be together with chiplets, so that our each die cost is low, so that overall cost of the package is lower than if we do a single ASIC, single monolithic big ASIC, right? That is we call modular design. So another
Hmm.
good thing about this modular design is you can miss can match, right? I mean, you can match, right? Like, oh, I need this, so in this package I'll put XYZ. Oh, I don't need Z in this package, so I'll put only X and Y, so that my cost will be lower. Okay,
Hmm.
so it's a modular kind of approach. So different functional blocks like chiplets can be integrated in a single package, so it will mix and match we can do. So also scalability, right? Let's say I want like lesser bandwidth, so I can put a chiplet which is lesser bandwidth thing, so that it is more cost efficient and more energy efficient. But if I need more bandwidth, I can put different chiplet. So I can use the same code chiplet, but periphery I can use different chiplets to make different packages to make it better, right? Also same is power efficiency also, right? So I can distribute the power. So each ASIC die can have different their power management, right? So you can do integrating power efficient chiplets alongside high performance ones to balance the overall power consumption, right? This will help in thermal management also, because each die will have their separate, means we can use the different characteristics of the thermal positions, optimal positions to help better thermal management, right? As in cost,
Okay.
also it is good flexibility. As I told, you can do tailored these things, right? So these things are mainly the kind of benefits of doing these chiplets.
Okay. Okay. So, out of curiosity, when I'm talking to you, a question arises in my mind that now we are trying to move from this unusual way of energy harvesting. I mean,
Okay.
So in networking, things also can be. I mean, is there any trend or any research going on, because you are all aware of networking things? So this inclusion of that thing, energy harvesting, like or I mean, not the mainstream energy thing, because I mean, um, do you understand my question?
Yeah, so you're
Alternative,
telling green energy, right? You're
green
talking
energy,
about.
exactly. Alternatives.
Yes, so that's what green energy is very important for networking also, because if you see in our, like, we have some ASIC routing boxes which takes like 30 40 kilowatt of power. It's a single box. It is taking 30-40 kilowatts of power, right? So it's a
Okay.
huge power consuming thing, right?
Hmm, hmm,
So
hmm,
our nowadays our main challenge or main focus is to keep the power low. Okay,
hmm,
so that is one of the major challenge. So not so that is one part of it, like reducing power and helping the environment. Another challenge is to where to get the power, right? Green energy and all those things. So I am very proud to say Juniper has have currently now runs a solar power plant in Karnataka. Okay, if you check,
wow.
you will see Juniper runs a solar power plant in Karnataka, and our energy comes from there. So I think our goal is to go zero carbon emission. Okay, in
Yes.
another few years. So that is a goal for Juniper also. So we already
Oh,
started that by creating a solar power plant in Karnataka. Okay, so maybe yeah, we'll reach there someday.
wow, that's a very positive step.
Yes.
Um, and since all, um, we are now going for making a semiconductor a big thing, and India is embarking on a new journey. So, what's
Yes.
your take on this? That in the whole ecosystem in this world, where we stand and where we can go, what your
Yeah.
take?
Yeah, so I think you guys already know that government has taken some initiatives, like he
Mm,
has launched India Semiconductor Mission, I think in December around 2021. So it is aiming to develop self-sustaining semiconductor ecosystem, right? India, right? So, though this initiative focus building semiconductor fabrication capabilities and promoting the fabrication compound and semiconductor, like silicon photonics, like nowadays, if you see the most of the power in our systems goes for optics, right? So that is also very important. So that is which is critical for power electronics and telecommunications. So I think government is giving some design in linked incentive also, so to give semiconductor design and product development. So I think government is doing
realized.
their part, right? So yeah, so they are doing their part. Okay. So if you see market size wise, I think India semiconductor market is projected to grow 64 billion by 2026, and maybe 110 billion dollar. I'm talking about dollar in
Mm,
2030, right? So, and by 2030, it will be representing maybe 10% of the global consumption, right? So yes, so India can contribute to 8 to 10% of the global semiconductor production by maybe another 1 or 2 years, if we supported by the government and the private investments. So one thing is good, that ultimately, if you see, you take any semiconductor company in the world, they have a India office, right? They have a India R&D center. Instead of office, you could call it R&D center. So they have a India R&D center, right? So the talent pool is already there. So everybody is making their thing ASICs and all from India only, right? So we have the talent pool, right? And we have strong educational institutions and focus programs, right? So that is very good. So overall, I feel that there we are in right track, but there are some challenges like supply chain resilience, right? So global supply chain disruptions during COVID pandemic, we see
mm,
that there
mm.
are, right? So there is, we are with the globally, they are very concentrated manufacturing hubs, right? So, what India needs is to build a resilient and diversified semiconductor ecosystem to mitigate such risks, right? So, we can opportunities there to address the supply chain challenges and foster like global partnership, right? You can do some
Yes.
partnership with people, right? And different companies, they can establish as a pivotal player in our industry. So there is we can do some infrastructure development also, right? So challenge is to do that modern semiconductor fabrication units, which require actually significant investments, right? So clean room, advanced manufacturing
Mm.
facilities, right? So maybe we can start with a little lower node, maybe 7 nanometer or 10 nanometer. Okay, instead of immediately starting with 3 or 2 nanometer process, that may be one of the look we can see. So main challenge in the semiconductor industry is to keep pace with the rapid technological advancements, right? In this AI,
Yes.
and high performance computing,
Mm.
next generation connectivity, right? That is the main challenge. But opportunity is there, like we can drive the demand. We have the demand, right? We have all the markets. So if you can produce and position as a leader, I think it will be very good. So I think that is there in India.
Mm. So, uh, is there any emerging trends in the move to more trend that can contribute in a better way for ASIC and networking devices? Any new
Yeah,
trend?
new trend means we see. Yes, I'll tell you one thing. So we all talk about this AI, right? So what is AI? AI and ML, whatever it is, let's say, what there are some GPUs or all these things are there, which is getting trained. Now, you might already know one GPU is not AI, right? One GPU is not. There are multiple thousands of GPUs working together, right?
Yes.
To make that model running, right? All this training, right? All we call training, AI training, ML, AI, ML training, right? You have to train the model, right? So this
Mm.
model, all the GPUs will work together to make the model done, right? Now the question is how these GPUs will talk to each other, right? They need to talk to each other using some networking, right? So they this is thousands of GPUs are there. How they'll talk to each other? They'll talk to each other. They need some networking, right? They need some switches, right, to talk to each other. So now our networking product is going in that AIML also, okay, so that they can connect the GPUs together. Okay, so that and we need to do this very efficient way and high low latency, high performance, right? Because otherwise their training will go for ages. Anyway, you know that this training is period is very high, so they are trying to optimize this training period and see how to reduce the time and all those things, right? So they create a model and then they share this model data with other GPU and all those things. So there is a lot of data going across these GPUs. So we are now creating the systems that will connect these GPUs together using the Ethernet technology, and that will improve this AI ML inference and modeling and training. So that is one of the major emerging trend that is coming up for the networking industry.
Completely different zone. I mean, I have not worked on although ASIC, but not for networking related.
Yeah.
And today's talk is so much lightly. You are sharing so much technical knowledge. Very engaging one. So when
So
you
if you
hire some,
if you any term or something, if you want me to explain more, because I think the viewers may need some more explanation,
yeah,
because
I
I'm
mean,
telling you terms. But if you think some explanation with this, because generally I talk to people who are like in my industry, right? So people tell a lot of
just because you are saying about the training of AI module,
things.
I just want to tell you one thing that when two users are using Chat GPT, after a few days, the search base or the answer it's giving very much aligned the same Chat GPT giving uh, slightly different. Is this
Yes,
ongoing? The training is also going that time when
yes,
depending on the user which kind of talk,
yes,
the
yes,
words he or she is using. That
yes.
means this training thing is always going on.
It is
It's
always
more,
going on.
so it's always optimize itself for a user.
Yes. Not only that, if
Okay.
you use this, I'll not say ChatGPT, this AI inference tools of two different companies, if you give the same question, it will give you
Yes.
different answers. Okay, not
Yes.
only that, if let's say you are using the same inference tool, but if your question format is different, you will get different answers. How
Yes.
you ask the question, the answers will be different. So that is what it is. See, it's like like a human. Na? If I ask
Hmm.
you differently, you will answer differently, right? So
Hmm.
that's how it is. So and the more you use it, it will tune to more of your liking, like or your way of doing things, right? So it
Yes.
will tune to you, right? So
Is
that's why it is.
observe quite well and try to understand the user's attitude, how it's respond, how it
Yes,
plays the questions. This way it answer said the
yes,
answers. Yes, I have
yes.
noticed that.
By the way, each of your query, whatever you give, it takes a lot of power to give you the answer. It burns a lot of power actually. People,
Mm.
it's in the background. People doesn't know, but all this data center and AI ML inference models is burning a lot of power. So
That
power is
Ghibli one was the owner said that our GPUs
less
are
than.
melting. Yes.
Yeah, so that's the thing.
So, I mean, when you hire someone for your team or in ASIC in networking, which kind of expertise you look for? And networking companies, which kind of expertise they need?
Yes, so we are recruiting. Means my team is recruiting only ASIC. We call ASIC front end. Front end means design and verification. Okay, that's what we this thing get. So the issue is it is not very easy to get ASIC plus networking knowledge in the market, right?
Hmm.
So generally, it is very difficult to get that you have ASIC knowledge and you have networking knowledge because very few companies do that kind of work in India. I'm talking about India recruiting only mainly. So many very few companies do work, and unfortunately, very few companies do very high technology work in India. Okay, so Juniper is one of the companies which does very high technology work in ASIC domain also in India. So it is very difficult to get. So that's why what we focus mainly is the ASIC knowledge, okay, the semiconductor knowledge or VLSI knowledge. If you are very good in VLSI or ASIC, then I think you can get trained on the networking protocols or networking methodologies and tools and all those things. So you can get trained on that. If you have networking knowledge, yes, that is very good.
That's
It's a
very good.
plus, very plus. But since it is difficult to get, we generally look for the people who has very good ASIC knowledge, who can do very good ASICs. If you can do very good ASICs, optimized ASIC, that is generally the our requirement criteria. And we do a lot of new college graduates also. We recruit, okay, so that we can they can get trained and get productive.
Do you offer internship for
Yes, we offer.
students?
Yes, we have offer internship. We do not much, very less quantity.
Mhm.
So, but we do internship for bachelors also and masters also. We have internship. Yes.
Okay. So this and what your advice would be, because you are working in this domain for so many years. So if any startup comes, so what would be your suggestion for them, for
Yeah,
startups?
as I was discussing startups, like see, manufacturing is very expensive. So we can, what we can do, we can start designing any because design knowledge is talent pool is there, right? Talent pool and knowledge is not a problem. We have talent pool and knowledge, and I feel there is lot of scope in ASIC designing in India also as a startup because there is lot of opportunity. All
Hmm.
these AI, email, and all those things are coming, right? This is just coming, okay, and you can do lot of things in India, which is like good talent pool and good investment and all. So you can do that, and government is also giving lot of incentive to do it in India, right? If you are doing a startup, I have seen they are giving quite a lot of good incentive to do things. So for startup, I think start with a good design, select the problem, which is not that you just want to reduce the cost, like, yeah, I'm doing it in India because I want to reduce the cost. Do that. Look for the global market. What is the gaps, where are we are not getting any things done in that space? You take that and then start, I think, your startup. I think there is a lot of, nowadays I am seeing a lot of things like kind of co-curricular startup, like mechanical and electronics coming together, okay, and electrical and electronics coming together, power electronics, okay,
Mm.
like power supply. Juniper recently did a collaboration with the Indian Institute of Science, Bangalore, for generating a next generation power supply. Because as you know, as I'm telling you, like 30 kilowatt or 40 kilowatt power you have to give to a system. How do you give that power, right? How do you give that power supply? Currently you don't have a solution. So any startup coming up with that and coming up with optimized and low cost solution, obviously they'll be very sought after. So that kind of gaps you have to figure it out, where it is not even available in throughout the world and you can do it. It is a good thing. You don't have to always create the ASIC or die, right? In electronics, there are a lot of other things you can do without the ASIC, right? ASIC people are doing. So other things also peripherals, a lot of things needs to be done.
Okay. Uh, as the technology is changing so fast in both the VLSI domain and networking domain, if a student now, after listening to me, and that question is for me also, do you suggest any reading material? Because I want to, I'm very finding it very interesting. After college, I think I have not much into this networking thing. So after talking to you, it sparking some interest. I want to read. Which do you suggest any book where I can get to, or
Yeah,
any site, anything?
yeah. So there's a lot of websites. Okay, so
Okay.
to go through in networking. So what I suggest is that start with the basic foundation one. So ultimately, people as the seven layers and all they have studied in electronics and communication of seven layers of networking, right?
Mm-hmm.
Five layer, back layer, and all those things. Layer one, layer two, like that. So start from there. Ultimately, it is all fundamental things only. Okay,
Okay.
fundamentals didn't change. Fundamentals didn't change. So you read a lot of things. There's a lot of podcast and YouTube videos and all those things are there. So nowadays, what I'm very good is that all these Coursera and courses are there, which is like online courses. And what is a lot of the Stanford University, MIT, they project their classes, networking classes and
Hmm.
all, they in online, right? So obviously it will be
Okay.
little higher grade. So initially you have to be there to understand what they are talking, but they are giving that. So if you can learn from a Stanford University professor, like what else
There's
can
nothing like it.
thing like that, right? Now you people have so much of opportunity these days to sit anywhere in the world and connect to anybody in
Yes.
the world, right? So that is the very good thing. If you want to learn, I don't think there is any barrier nowadays.
Okay.
So
So, lastly, what excites you about the future of ASIC and networking and technology? Which aspect excites you?
yeah, aspect is like I'm so many years in networking and ASIC, but every day I'm still learning. There's still new things coming up, right? So that's what still excites me. It is like there is no dead end. I don't see any end because after so many years of networking, there's new standards coming up. There are new things coming up. ASIC also every day we are solving new issues, new problems. Okay,
Hmm.
7 nanometer, thin nanometer. Now next will be 2 nanometer. You don't know where it is going. All this certain chiplet. We didn't know this chiplet technology 10 years back, right? Nobody knew. Now
Yes.
all this technology is there. Then there's this 2D, 5D, sorry, 2.5D is
2.5.
technology, memory technology, HBM, and all those things. It is combining and doing so many good things, and those are very very new technologies, right? So, and people are very innovative to come. So innovation is coming every day. So many patents and all those things people are filing and they're doing, right? So that means we are doing new things, right? As long as we do new things, I think it will keep us excited and all those things, right? So that's what excites me. New things every day, new problems, new solutions.
And those who are joining industry in this era of AI and ML, what's your suggestion for those freshers?
Yeah, so what I feel is that you have to be your fundamentals should be there. Okay. So fundamentals is the basic thing. Whatever AI is telling, if you don't understand what they are, right? So it's basically mathematics. Nowadays, mathematics has become very important now, right? Linear algebra, statistics, and all those things you need to know if you are looking for AI ML, right? Programming skills, yes, I think most of the people know, but this nowadays Python and TensorFlow libraries like TensorFlow, PyTorch, all those things you need to know. Gain practical experience, like you work on projects, okay, which you think it will be used in real world, okay, by applying your theoretical knowledge, right? This would including like participating in hackathons, contributing open source projects, okay, developing your own applications, AIML applications. And you told, right, internship, you can get internship in some companies or part-time roles, okay, that is also give you the industry experience.
Mhm.
And then you have to be updated with the industry trends, right? Online courses, certifications, research paper. That's what we have told you, right? There is something called GitHub repository is there,
Yes.
which showcasing your project's code and contributions. You can do blogging or writing, okay? Write about your projects, challenges, okay? And community involvement, right? Networking is not in networking our thing, but it is like join the communities, okay? This LinkedIn and conferences keep on happening, so you should do that. And after some time, after you understand all those things, focus on a specialization, right? So identify which interests you in this field. AIML is a very broad field, right? But there is like this networking or computer vision or natural language processing or reinforcement learning. All those things you identify your interest, and then you go there and become a specialist there, right? And there is a lot of advanced topics are also there, like deep learning, generative models, and all these things. And top of all, I would suggest people to have your soft skills and problem solving capability, right? So critical thinking to develop like problem solving, out of the box thinking. Ultimately, everybody is solving some or other problem, right? So you have
Yes.
to solve the problem, right? And effective communication. So if you cannot communicate what you're thinking, right, then it will not work, right? So it is crucial to explain what your work you want to do, okay? So maybe
Mhm.
you're communicating with a person who is non-technical, right? So then you have to talk like that. So that is also very important, right? So these are the main things I would suggest for people who are looking for starting with email and all things, right?
Uh, since more and more states are making their own semiconductor policy and more states are including, so I mean, I hope that Eastern India also gets something
Yes, I think
one
it's
day.
already started. I think Orissa already have a policy.
Uh,
West
um,
Bengal government also, what I heard is that they are making a policy for semiconductor. So maybe it will come very soon.
expect to get more companies in Kolkata and other
Yes,
eastern cities. Let's see.
yes,
Hope for
yes,
the best. I
yes. That
think
this place should help to spread the awareness of that things that can happen in Calcutta also. So that
yeah, obviously it will happen because I mean, what's actually different is there? I mean, even 25 years ago, Hyderabad or Bangalore was not like what
correct.
it's today now. So at some point, something has to get started. It has to start somewhere. So I think within few years here also we can have some more companies. Already in Bhubaneswar is there. In Assam, Guwahati is coming up,
Yeah,
and in
trying to
Bihar
send.
also there is one company, is Chip Semi. I
Mm.
have talked to Chandan Raj from Chip Semi. He has started his company in Bihar. Let's see. Hope we will have a better condition here for ASIC and VLSI domain. So
Sure.
these were questions from our side. Do you want to share from your side? You want to share anything specific you have in your mind, which I have not covered?
I think mostly I think you have covered most of the things. So I would suggest people to work on electronics and the semiconductor industry, whoever is aspiring to go, okay? So one thing is that I am available in LinkedIn if you want to connect with me, okay? I have some questions, I am always available to answer your questions. So I want to help people, okay, to grow, okay, and to become successful, right? That is, I think, if everybody becomes successful, then only we'll grow, right? So what you told about Calcutta and West Bengal and Eastern India, so I am seeing a lot of traction in Eastern India. A lot of people wants to come to Eastern India. So and yes, I am there to help, and we can definitely make things much better moving forward.
Networking, collaboration, this is
Yes,
required.
yes, yes.
And this will happen, obviously this will happen. More and more, from this side, I can see after each and every episode of TSP, I'm getting
Hmm.
connected to few more people.
Very good.
Recently, after one episode, from
Hmm.
someone from abroad, they sent
Hmm.
us direct message that
Hmm.
yes, we want to get connected, because just because of the algorithm, not always I can see others. Even they are directly connect with me, I cannot see their message, or vice versa.
Okay.
So we
Okay.
have sent out an open message that if you think you have a story to share, you have some insight to share, please come and join us. It's your it's your place. Come. We
Correct.
have no reservation. Please come and share your story, what experience you want to share. It's for the community. So people are responding to it, and it's so new people never
Yes.
knew that these kind of companies are there, these kind of groups are there. So people are
Yes.
we are connecting.
Yes.
So
Yes.
I think
Yes.
connection and networking, that will grow. More people
Yes.
will collab.
Yes. Yes. I think so. So I think I'm seeing a lot of good vibes now here. So we are
Yeah.
getting a lot of vibes.
Yeah.
So,
So,
so actually,
okay.
if you see, getting office space in Sector 5 is becoming very difficult nowadays. There is no space. So that
Wow.
much of is there. Yeah. If you ask for
Okay.
for space, they're telling very difficult to get the space.
So
So things
more tech park will. We
needed.
have to build more tech parks.
Yes, yes,
Needed.
yes. Yes,
Good.
yes. It's good.
Would love to see
Yes.
bustling tech city in
Yeah.
one part of Kolkata. Would love to see. I started
Yeah.
my career from Kolkata,
Oh, very
in
good.
Intera, and then
Okay.
everything wrapped up, and the whole division was divided into two part project
Yes.
wise. Few people went to Noida, and we went to, because we were in TI project, so we went to Bangalore.
Nice.
So, and never got back to Kolkata. Always in either in NCR or in Bangalore.
Okay.
So hope we will get something. Okay, so we had all these questions for you, and it has been a very nice technical discussion. So many points you touched. Thank you very much
It's
for
nice.
coming to TSP and spending some valuable insight on the subject. So we will end our session here today, and viewers, do subscribe to our channel and follow TSP. This is our technical domain, and we talk about technology here. So thank you for staying
Thank
up
you.
to this point, and bye for today.
Thank you. Bye.
Bye.